Okay, I want to point out a few things about our calendar here. So there's map testing that's going to go on tomorrow and Wednesday. So the advisement periods are going to be a little bit extended on both those days. So I want to make sure that we have enough time for our test. So I'm moving the test to Thursday, but I don't want to lose a day of instruction. So I'm going to be flipping those days here. So I'm going to be on Wednesday, I'll cover 2.1, 2.2 notes that was meant for Wednesday, that was meant for Thursday, flip on Wednesday, and then the chapter 1 test on Thursday. Okay, and I'll have a test morning review, 7:15 a.m. On Thursday. Okay. But we're going to be spending today and tomorrow, dedicate these 2 days for test review. So on Wednesday, I'm not going to do any test review. I want to start the next unit. Obviously, next unit is not going to be on chapter 1 test. Okay. And then Thursday morning, test review and Thursday test. Any questions about that change? And then the homework that that will be assigned on Wednesday, I'll check that homework on Friday. Okay, so Thursday you're just taking the test. I'm not gonna check any homework. I'll check the 2.1, 2.2 homework on Friday. Okay, so the next thing is I sent you guys a remind about signing up for AP Classroom. So at the end of class, I'll let you guys get your phones. And if you guys can go ahead and just do this now, so it'll take like a minute, just get it out of the way. And I'll put the join code here where you can make sure that you join. So you're doing 2 things here. One, you are you're signing up for your AP exam. And the second thing is that you have access to AP Classroom. And I'm going to release all the notes and videos that AP Classroom has to offer. They have great videos of these teachers going through each of the topics, and they have lessons and videos and practice tests. So I'm going to open all that up to you. I'm not going to have, I know some teachers, they have assignments through AP Classroom, but I'm not going to have that as assignments. So I'm just going to let that be a place where you can just explore, and if you want to do extra practice, or if you want to just whatever's available on it, I'll try to assign that to you, but it's not going to be for a grade. It's just for just at your discretion whether you want to use it or not. Okay. Yeah, just know that, let's see, it says the final ordering deadline is Wednesday, November 15th. After that, any orders will incur the $40 late registration fee. So I'm hoping that we can get it all done this week. So, and if you haven't signed up for it, I'm going to be checking you off and just making sure that nobody accidentally doesn't sign up, so that we can just get that out of the way. Okay. Okay, so we started our test review on Friday. We're going to continue. I know we did page 1, number 1. Did we do number 2? Did we finish this continuity problem? We did? Okay. So let's look at number 3. This is another continuity problem, because you see the word find the k-value that will make the function continuous. Don't worry about the fact that, wait, what do I need to do to solve for k? Just walk through your continuity conditions, and before you know it, you're going to be able to solve for k without even trying to solve it. Okay, because you're just walking through continuity conditions and making sure that every condition that you're naming it, that you're just going through the notations, and we should be able to solve for k. All right, so we have our function, x squared plus x minus 6 over x plus 3, where x doesn't equal to -3. That means that this graph lives everywhere except -3. So this is where the graph is. And then this is just a point. Okay, so maybe the graph looks like this. But we know that everything here is within the connected graph. And we know that the connected parts of graph is where your limit is going to be found, right? Your limit is not going to be found with the point. It's going to be with your connected sets of graphs. Okay, so let's go through our continuity conditions here. First is identify the point. So we say f of what? What's our x value? What's our c value in question here? Yeah, we know that any restriction they give you, that is what they want you to work on. So you know you're working on -3. So f of -3 is equal to. Okay, so we don't know what k is, but it's okay. We're just gathering information, right? Okay, second condition. Does the limit exist? All right, so can we use one limit notation or do we need two? Just one. Yeah. If you see less than, greater than, then you have two separate graphs, then you have to use two limit notations, but there's only one graph, right? Or no, one connected a piece of connected part of graphs here. So it's only going to be with that first expression. So limit, only one limit notation needed, x approaching -3. All right. We know this is approaching a real number. So what's our first step? Yeah, direct substitution, right? So -3 gets used, gets plugged in. All right. What do we get? 0 over 0. Good. So we know that there's a hole. We're going to continue working, trying to get that hole resolved. Yep, we go ahead and factor. Multiply -6, adds it to 1. 3 from 3. Let's see. Should be 3 -2. Yeah, that's right. So x plus 3, x minus 2. Reevaluate and we get 1. So we have our second condition found. We're going to keep going, right? Because we're just walking through each of our conditions here. The third condition, what's our third condition? Is 1 equal to the other. Yeah. So we need, it says it's continuous, so every condition has to pass. So we know that f of -3 must be equal to the limit. It's not. As x approaches -3 of f of x. So what can we say? They're not equal. Well, we don't know what k is, right? But k has to be equal to what? -5, right? So k equals -5. Right? It's not like -4 equal to -5 where we say, oh, that's obviously not the same. But they left that k there so that we can have that flexibility of basically filling in that hole. So if we let k equal to -5, then everything works, right? -5, limit is -5, the order pair and limit equals. So without even having to do anything more than than continuity conditions, you solve for k. Yeah. I didn't know k equals -5 because. Well, we don't know what k is, but we do know that k has to be a value that makes the function continuous because they're telling us that the function is continuous. Oh, right. So it's not like we have to decide whether it's continuous or not. They're telling us it has to be continuous, so we have to choose a value that will make things work. Okay.
What did it say? Make a value continuous, but then it doesn't pass on the first two steps, or you.
Well, if it's giving you, if it's asking you to find a value that makes the function continuous, then you're going to be able to find that value, right? You won't have anything that is contradicting that. Yeah. Now, if it's a full blown expression, let's say they say that at -3 the value is 4, right? If there's no unknown value there, then you'll walk through and they'll ask you, okay, is it continuous? And then you can decide whether it is. But here they're giving you that unknown variable to ask you to fill in what makes it continuous. Yeah.
Did we just write k equals -5, or do you want to start speed?
Yeah, just k equals -5. That's good enough. Yeah. Okay. Next page. Okay, so these are some practice just from your quiz, basically. So you guys want to try that? 1, 2, and 3. Try number 1. Go through your steps. So these should feel very familiar because you guys were able to demonstrate your knowledge of this on your quiz.
Number 2, 3, or 4?
Oh, X approaches 9. It's hard to see. Yeah, sorry. X approaches 9. Number 2. Okay, good. Okay, great. Okay, so number 1, direct substitution. We see 0 over 0. We know that we have to go through, in this case, factoring. So factoring. The x minus 2 and 2 minus x, they're really close, but they're off by a factor of -1. So I can just factor -1 from one of them, and I can cancel, reevaluate, just make sure there's -1 left over. So -1 times 5 is -5. Okay, number 2, direct substitution also gives you 0 over 0. So you can recognize that as a conjugate method problem there, having to multiply numerator and denominator by the root x minus 5 plus 2. We said that we expand the numerator, but we leave the denominator alone because the x minus 9s will match up nicely.
There's no need to mess that up in the denominator. Leave it in factor form. And then make sure at the end that you reevaluate. Remember, you're trying to reach a number, so you don't want to just leave your answer with the x's in there. You want to reevaluate, get that 9 to get inserted back into the expression. There's a 1 left over in the numerator, 1/4. Okay, I'll walk through. I'll show the steps for number 3 since this is a little bit more involved here. Everybody good with 2? Right. Complex fraction, we know that direct substitution gives us 0/0. We have to step to the side here and work on trying to get that expression to clean up a bit. And by cleaning up, I mean merging it into the same fraction, but we got to do common denominator first, right? So what's our common denominator for these two denominators here? 2x, right? We need the x and we need a 2. So we ask, what is going to allow this to balance? X times what gives us 2x is missing a 2. So I need to add a 2 to the top, multiply top by 2. This 2 is missing an x, so 1 times x is x. Okay, so this is what we're going to replace that numerator now that it's cleaned up a bit. All right, so we know that at the very beginning of the problem, we should already know, okay, we're trying to find something to match with this x minus 2, right? This x minus 2 is always causing a 0. There must be an x minus 2 hiding in here that's causing 0. So we see that beginning to form, right? It's not quite x minus 2, but it is 2 minus x, and you do see enough similarity there to continue exploring. So let's undo this complex fraction here, right? Dividing by a value is same thing as multiplying by its reciprocal. We know we can factor a -1 out of both of these. So I'm just going to cancel out and make sure I keep track of -1. So now that I have the whole removed, re-evaluate. Replace 2 in for all the x, so -1/4. Okay, quick review from the quiz topics.
Like, I have the same answer, but I did it kind of a different way. I don't know, that's
That should be fine. Let me see.
like. I brought the 2x over. And took a -1 out. So good. So we had this, and that being negative, so it's well.
Yeah, I think we got the same thing, right?
Yeah, but like, doesn't matter what method.
No, as long as you show your steps and that you're not breaking any algebraic rules. Yeah, you may have a slightly different step than me, but.
So the 2 minus x just goes away for the -1. Oh. Easy factor to -1.
Yeah, because that factor, I skipped that step. I skipped the factoring a -1. I canceled them out and I knew there was -1 left over. I think 4 is good, similar to what you did with what we did on page 1. Let me, and then 5 is a bit more challenging, but we can come back to 4 and 5. And 6 is just finding vertical asymptotes. So let's go to, let's skip those. I want to go to page 3 and do another variation of the piecewise, walking through that. So. Oh, sorry. Page 3 is page 5. Okay, so again, we see some piecewise functions here. We know that the connected parts of graph are here, and then we know the order pairs are in between here. So just know that the x, 12 comma x equals 2. That's just a point. That's just a point, but we have 3 segments, and each segment kind of takes its own region. You got a region to the left of 2, you got a region between 2 and 5, and you got another graph that's showing to the right of 5. So let's look at part A. All right, limit as x approaches big infinity. We have to decide. We obviously never want to touch the point, right? The point is not going to give us anything limit related. It will give us ordered pairs, but it will not give us anything limit related. Okay, so approaching negative infinity, which piecewise do we want to, which expression do we want to use for that? Good, right? We see x is less than 2. That is definitely something that is living in this region here, the left of negative infinity. So we're left with 2 is approaching negative infinity. So x plus 5 or 2x minus 4. Okay, so now we can go through our steps, right? So we see approaching infinity or negative infinity. What do we do here? Do we do direct substitution? All right, no direct substitution, right? That's only for real numbers. So what do we do if we see infinity? That is after we get something right. We always do what? Compare what? Compare degrees, right? So compare degrees. If the degrees numerator is higher, then we do plus or minus infinity, right? Then we test, but we don't know what category we're in yet. So we want to compare degrees first. Okay, what is degree comparison tell you? They're the same. So there is a horizontal asymptote, which is the same thing as limit. What's the limit going to be? 1/2, right? Just the ratio of the coefficients. Now, if the degree was higher than the numerator, then you have to consider, okay, maybe I got to test 100 or negative 100 to try to get that, get those those two options to show. Okay, what about approaching 2 from the left side of 2?
Same one.
Same one, good.
Would it be the same answer?
Well,
Oh, actually.
it's a little bit different, right? What's different about A and B? Yeah, you got infinity, which is a different thing than a number, right? So how do we handle a numeric value?
Plug it in.
Plug it in, right? Okay, plug in. So what does that tell? What does that give us?
Number 0.
7/0. Okay, that's very telling, right? This is very important that we do direct substitution because it's going to tell us what's going on. What's going on at 2?
Vertical asymptote at 7.
Yep. Vertical asymptote at 2, right? Yeah, but there's vertical asymptote with the 7/0 tells us what there's vertical asymptote. So what do we say from here? How do we move forward? Okay, well, we know the limit, what? The full limit would be what? Does not exist, right? But it's asking for the full limit. It's not, right? So if you see these two paired together, you know decimals are involved, right? There's going to be, you see it approaching from one side towards an asymptote. There must be a decimal involved because the whole idea is that you're choosing between two options. The reason again that we do decimals is because we're kind of stuck between two options and we're trying to narrow down our choice. Okay, so what's a good value for us to use to test? Yeah, 1.9. We don't care about the decimal value per se. We just care about whether the result will give us positive or negative. So 1.5 in for the numerator. I get 1.9 plus 5. What's that?
Positive.
Positive. Okay. And then bottom 2 times 1.9 minus 4. Now we know 2 times 2 is 4. So 2 times 1.9 is going to be a value slightly less than 4, like 3 point something, 3.8. So 3.8 minus 4 is negative. Positive or negative is negative. So negative. Two from the right. What do we choose? 2 from the right. Okay, yep, that's slightly to the right of, and that, well, 2 to the right is definitely between 2 and 5, so 2x minus 5.
Negative.
Yeah. Direct substitution, -1, no decimals, right? There's nothing that tells us to use decimal. We're just deciding how is the graph moving as it approaches 2 from the right, okay? Okay, limit as x approaches 2, would you say 12?
12. Actually, never mind.
No, because it's
It's approaching 2, right? Now, let's say I asked you what f of 2 was. If I asked you what f of 2 was, then that's perfect, right? That the point is f of 2 is 12. That's good, but it's asking for the limit. So the limit is talking about the approach. Is there something that we can use to help us?
You do both sides to the limit.
Okay.
To do the x plus 5 divided by 2x minus 4, but then you also do the 2x minus 5.
The whole, what would you conclude?
I don't know.
Do we have something that we've already gathered that can help us with part D?
Yes. -1 and then
Mm-hmm.
negative infinity.
All right, so this is approaching that target from both sides. What does this tell you? Yeah. You mean between B and C? So we only test a decimal if we realize that there's a vertical asymptote and it's a one-side limit. But for C, what do we do when we do direct substitution? We got a real number, right? So that means there is no vertical asymptote, at least not from this side. Right? That is, if it's a real number, there's no need for us to do decimals. Right? You only do decimals if you realize it's the. Now, obviously, okay, there is vertical asymptote coming from this side, but from the other side, there is no asymptote. The only reason that we can do that is because these are piecewise functions, right? There's no one function. Usually a function is going to be asymptote, but here you have all these different sets of different functions that are piled on top of each other. That's the only reason why we're able to create this piecewise function. You're taking different pieces from different functions and putting it, kind of piecemealing together, making it a piecewise. So what does this tell you then, these two numbers?
We'll ask, it's a -1.
Okay, why would you say that the limit doesn't exist? Right, in order for a limit to exist, what needs to happen? Both arrows have to approach the same real number y value, right? So here, this is basically representing the arrow coming from the right. This is the arrow coming from the left, and one's going to -infinity, the other's going to -1, and there's obviously a disconnect, right? Unless they move to the same y value, it's the only way that we can say limit. Yeah, jump discontinuity, but we don't have to categorize. We can just say limit doesn't exist. You only have to categorize if I ask you, hey, decide what type of discontinuity, right? Then you have to decide.
So the point ones are just like distractors then.
Which parts like structure?
Remember how I actually thought it was like x equals 2 is 12?
It is, well, I mean, you can think, yeah, it is a distractor. But if if there was a different question, let's say, another question I was asking f of 2 equals 12, then you would use that, right? So on this example, I didn't ask you for any ordered pairs, but on the test, I may ask you for an ordered pair. So just know the distinction, when to look for an ordered pair and when to avoid it. Okay, part E. Okay, approaching 5 from the left of 5. Which piecewise do we use for that? Yeah, to the left of 5, that's going to be in this range, right? Between 2 and 5. So we use that 2x minus 5. That's the first step.
Plugging the 5.
Direct substitution, what do we get?
5.
Yeah, so there's no need to do anything else, right? We have a real number, so no decimals. No need to do anything with that. There's no vertical asymptote. Nothing is telling us that to do that. Five from the right. Okay, thank you.
Minus x squared plus 4 divided by x.
Okay. All right, what's our first step?
Plug in.
Plug in, okay? What is so we get the negative. Yeah, the negative comes after the square, so that's 25. Then make it negative 25. Negative 25 plus 4. Yeah, negative 21 over what? 0. What does that tell us? What's happening there? Vertical asymptote. Normally, you would say the limit doesn't exist, but do we have to go any step further?
Yes.
Yes, it's approaching from the right side of a vertical asymptote, so we know that. We know it's one of these options, right? Either the graph is doing this or it's doing this as it approaches that vertical asymptote. We got to decide, right? It's not both. It's only one of the two. So what can we use?
5.1.
5.1. Yeah.
Both be negative, right?
Yeah. So we got a negative over a negative, therefore
Positive.
positive infinity.
The whole limit as a whole won't exist.
Yep. And why do you say that?
You start on different. They kept discontinuity.
Yeah. The approach from both sides are not consistent, right? And we don't want to look at the order pair, right? The order pair, this 20 is not giving us anything, right? It's not giving anything, any indication what the limit is, so we don't look at that. Okay, 3 from the right. Choose 3 from the right.
Minus, well, the only one that you can guarantee where it's 3 to the right is the minus x plus 4. It's for the middle one, you can't really guarantee.
Well,
Oh.
3 is between what values here? Is 3 to the right of 5, or is it between 2 and 5? between 2 and 5, right? So we choose the X value where it lands, right? Yeah, because this X greater than 5, it's not in that range, right? It's a different graph for X equals 3 versus to the right of 5. So we use that 2X minus 5. All right, first step.
Plug in
Mm-hmm.
it's 1.
It's 1. Anything more to do?
No.
No. If it's a real number, we can stop. Okay, approaching infinity.
Minus x squared plus 4 divided by
Yeah, this definitely to the right of 5, right?
Yeah. the numerator has the highest degree.
Mhm.
So
Yeah, so why do we not plug in like the other ones? Yes, infinity, right? We have a different set of rules, right? We said different set of rules when we did A versus B, right? Compared degrees with infinity. Again, we compared degrees. Okay, Connor, what you say?
so that the numerator degree is higher than the denominator. So we can do like some sort of process or something.
Mm-hmm.
Forget what it is.
Because we know that is there going to be a horizontal asymptote here? Degree's too high, right? So that means this fraction is either going to go where? Up towards positivity, or it's going to go down without bound to negative infinity. So if we're choosing between these two options and we're headed towards infinity, what can we test?
5.1.
100.
Right, you want to choose a large number in the direction of infinity, right? So let's move to a large number like 100.
For negative infinity, be negative 100 meters. I see.
Yes, right, yeah. If it's approaching infinity and the degree is higher, then you do negative. But if it's negative infinity and the degrees are the same, then we should look at the ratio, right?
Yeah. Negative or negative.
Yeah, which is
That's positive.
positive. All right, so this page is a little bit more involved than Friday. I mean, we still went through the same steps, right? Decide which expression went with which limit, but a little bit more involved because the fractions forces us to have to deal with more things to consider, right? Do we compare degrees? Do we plug in a value? If we plug in a value, how do we know when to stop? How do we know when to use decimals? Right? I think that's the biggest challenge when everything gets mixed together. Right? Okay. Any questions here? Any ones you want me to further explain or re-explain?
So will it be like just like this on the test? Like
Yeah, very similar. Mhm. Okay. Yeah, let's see if we can. Let's see. Hold on.
Do you say you're gonna go back to like those multiple choice ones?
I will. Yeah, yeah. So tomorrow, tomorrow we'll finish worksheet 2. We'll go back to worksheet 1 and we'll highlight some of the problems. I mean, there's no homework, but if you guys can just look through the packet and work additional problems, that'll be great because your test is not until Thursday, but if you can do a little each day, I think that will really help give you, so you're not waiting till the last minute to study. Guys, if you can get your phones, if you can do this for me right now, so you can just take this, it takes 5 minutes. Okay. Yeah, right. Yeah. I would copy out those. Yeah, so this is the graph that.
Oh yeah, wait, that's good.
Okay, this is blank, but then for 9, just fill in. Sorry. Oh, yeah.
Yeah, Jay's little brother's actually.
So like.
Sorry, no, I think for both of these, I'm gonna ask you to sketch them. Both of these, because I gave you all the properties, so you're sketching.
Oh, okay. Where's most of Oh.
Yeah.
How do I, do you want me to send you anything? Or-
Yeah, I think it's through comment.
Okay,
Yeah, so you just.
just request it from there.
Okay, so, guys, you're gonna go to, apcentral.collegeboard.org. I'm gonna put that website up at the top here, apcentral.collegeboard.org. I think many of you guys have taken an AP exam in the past, so I think you should have an account already. And then you're gonna click on sign into AP Classroom. And then once you create an account, you'll be able to log in and use the join code. So they put all the AP calculus, AP classes just under one section. I know some of you guys already done it yesterday, but I want to see if you guys can just get it all done in class here. I see that you guys are joining. Thanks for doing that. Okay, if you haven't signed up, you may get me sending you text remind just to bug you to go ahead and sign up. Because the longer that we wait, the easier it is to forget about doing it, so.
Shane, will you have such a tomorrow morning?
Not a formal